beautiful people, and welcome. In this video, we are talking about solving equations with variable exponents. Now, what does that mean? That means that you will have a variable, a letter, in the exponent spot. And what you're trying to do is you're trying to solve for that exponent. As always, disclaimer time, I am human. If I make a mistake, that's okay. Just let me know where the mistake occurs so that way I may learn from it. The very first thing I want to start off with is a property. It's the same base property. You can maybe hear it as called base property. Sometimes I will call it a one-to-one rule. That means if you have the base, if you have two things and the bases are the same, however, the exponents are different, what you can do is you can set the exponents equal to each other. And you can only do this if the bases are the same. If they are not the same, then you can't do it. I'm going to even highlight that. The bases have to be the same. Let me do an example for you. For an example, we have 2 to the power of x minus, just kidding, this is a plus. 2 to the power of x plus 6 is equal to 2 to the power of 5. So x plus 6, all of this is your exponent, and 5 is an exponent. Your base is 2 on each side, so your bases are the same. And this only works if there's nothing else there. So if you have a number in front of your base, like 3 times, you can't do that. It has to be only the base, and the exponent. So now that we have the bases are the same, we're going to use that one-to-one rule and say that x plus 6 is equal to 5. And now you're going to solve for your x value by doing what we did in the beginning of the school year. Dotted line, we're going to subtract by 6 both sides. X is now equal to a minus 1. So, you can write the answer like this. Let me shift this up. Or you can say 2 to the minus 1 plus 6 is equal to 2 to the 5 power. Up to you. So for example 2, we have another, obviously we have another example. So here is our base, which is 9. Here is our exponent, 2x minus 5. Now, if we look at the other side, this 81 has no base and has no exponent because it has no exponent. This is no base, no exponent. So how do we solve something like this? When we have a question like this, we want to be a little bit forceful. We want to force the problem to do what we want it to do. How do we do that? Copy down the numbers with the base already. So 9 to the 2x minus 5 power. On the other side, we're going to force this 9 to match the other side. So I'm going to put a 9 here. Now 9 and 81 are not the same. 9 is not equal to 81. If I want $9 or I want $81, I want 81 because 81 is a lot more money. So how do we make sure that these two are equal? So you're going to make equal. And the way that you make equal is you're going to put an exponent there. So we have to figure out 9 to what power. So you're going to use a caret. 9 to what power? Let's do 5. And we want this number to be 81. So this is not true. We need something smaller. Let's do 3. Still too big. Let's do 2. And 9 to the second power is 81. So right here, I'm going to put a 2. Because 9 squared, this is why I'm doing this, 9 squared is 81. So I'm going to write 9 squared here. After that, it's pretty much exactly what we did before. These bases are now the same, so the exponents are equal. So I have 2x minus 5. We're going to simplify and solve the equation. I'm going to add 5 to both sides, just like we did previously in the school year. 5, 6, 7, so I have 2x. I'm going to divide by 2 both sides. X is equal to 7 halves. Now, again, it doesn't have to be a pretty number. It is what it is. X is equal to 7 halves. All right, beautiful people, we will do lots more practice in class. Thank you so much for watching my video, and I will see you in the next one. Bye.